Hi guys, today in this video, I'm gonna teach you how to do word problem related to distance, velocity, and acceleration. This is really helpful for exam because the AP exam oftentimes put questions, word problem related to distance, velocity, and acceleration. Even in the multiple choice section, they also put this type of problem. So one thing you have to keep in mind is that distance, velocity, and acceleration are related to one another. If the distance is the original function, the velocity is the first derivative of the original function, and then the acceleration is the second derivative of the original function. So we can actually find all of those if we know one of the function. For example, if we know the distance, we can know the velocity and acceleration. If we know the velocity, we can know the acceleration and the distance. And if we know the acceleration, we can know the distance and the velocity using both integral and also derivative. So now we're gonna move on to the practice problem, because I think that's the easiest to be able to master this type of question and to help you understand more. So here I have a practice problem that I made by myself, so I'm so sorry if the number is so bad. Yeah, so here it says a particle move along a straight line. The velocity of the particle is given by vt equals t to the third power plus 4t squared plus 6t plus 7. And the position of the particle is given by s parentheses t. It is known that s0 is 10. Find the position of the particle at time t equals 5. So the first thing that we have to know is that position is the same as distance. And as I said earlier, distance is the integral of velocity. So now we know what to find. So to find the distance, which is s5, we have to do the integral, and the lower bound is 0 and the upper bound is 5, since this is 5. Because it starts at time 0 and it ends at 5. And then we put in the equation. And then we have to remember that the problem gives us the initial condition, which means that it starts at this position, so we have to include it in the equation. So after the integral, we have to add by 10. So just keep it in mind that the initial condition have to take into account when they're asking about the position at at particular time. So here we can use calculator if they allow you to use calculator, or we can just plug it in. I bet you guys know how to do the integral of this. This is I'm just gonna do it really fast, and then plus 10. Don't forget to always put the initial condition, and then we plug it in. 5 to the 4th power is 625 over 4 plus 500 over 3 plus 75, and then plus 35. And then because this is 0, we don't need to minus 0. Plus 10 equals this. We can just plug it into calculator. I'm just gonna plug it in. 625 divided by 4 plus 500 divided by 3 plus 75 plus 35 plus 10. This is gonna be 442.9. So here, this is the final answer for the position. Again, the the number is bad because I just made the question up. So now we're moving on to number B. Here it's asking about what is the acceleration of the particle in time t equals 3. So again, as I said before, acceleration is the derivative of velocity. So what we have to do is find the derivative of the velocity, which is 3t squared plus 8t plus 6. And then because it's given for us to find the acceleration of the particle at time equals t, then we just need to plug it in to this equation with t as 3. 3 times 9 plus 8 times 3 plus 6, 27 plus 24 plus 6, and then it becomes 27 plus 30, and it becomes 57. So this is the answer for acceleration at time t equals 3. Thank you for watching. I hope this helps.